Myself, MA Mahant, working in Computer Science and Engineering Department as an assistant professor in Walchand Institute of Technology, Solapur. Today we are going to see the one topic of Internet of Things, that is sensor technology used in IoT. Learning outcome. At the end of this session, student will be able to describe sensor technology used in Internet of Things. First, we are going to see the introduction part. Generally, sensors are used in the architecture of IoT devices. Sensors are used for sensing things and devices, etc. A device that provides a usable output in response to a specified measurement. The sensor attains a physical parameter and converts it into signal suitable for processing. For example, electrical, mechanical, or optical form. The characteristics of any device or material to detect the presence of a particular physical quantity. The output of the sensor is a signal which is converted to a human readable form, like change in characteristics, changes in resistance, capacitance, etc. Now this is the block diagram of the IoT hardware regarding the sensor. So in this part we are going to see three components: sensor, processor and actuator. So input is given to the sensor in any form, and this is called a transducer's input, which are giving to the next unit, that is processing unit, and in this unit the things are going to process, and the output is given to the actual actuators, and this is the actual output which the user can be using it. So this block diagram consists transducer's input and transducer's output. So this is the block diagram of IoT hardware. Now, what is the meaning of transducer? So, a transducer converts a signal from one physical structure to another. It converts one type of energy into another type. It might be used as actuator in various systems in IoT. Now we are going to see the sensor characteristics. Sensor characteristics have been divided into two types. One is static characteristics and dynamic characteristics. It is about how the output of a sensor change in response to an input change after steady state condition. The first static characteristics, accuracy. Accuracy is the capability of measuring instrument to give a result close to the true value of the measured quantity, and it measure errors. It is measured by absolute and relative errors. Express the correctness of the output compared to the higher priority system. Absolute error equal to measured value minus true value. Relative error is equal to measured value divided by true value. The range is another characteristics gives the highest and lowest value of the physical quantity within which the sensor can actually sense. The next static characteristics is resolution. Resolution is an important specification of selection of sensor. The higher the resolution, better the precision. When the acceleration is 0 to, it is called a threshold, provide the smallest change in the input that a sensor is able to sense. Precision, the next characteristics. It is the capacity of a measuring instrument to give the same reading when repetitively measuring the same quantity under the same prescribed condition. It is necessary but not sufficient condition for accuracy. The next characteristics is sensitivity. Sensitivity indicates the ratio of incremental change in the response of the system within respect to incremental change in the input parameter. It is the smallest amount of difference in quantity that will change the instrument's reading. The next characteristic is linearity. The deviation of the sensor value curve from a particularly straight line. Linearity is determined by the calibration curve. The static calibration curve is plot the output amplitude versus input amplitude under the static condition, and a curve slope resemblance to a straight line described linearly. The next characteristic is drift. The difference is the measurement of the sensor from specific reading when kept at that value for a long period of time. Repeatability. The deviation between the measurements in sequence under the same condition. The measurements have to be made under a short enough time duration so as not to allow significant long-term drift. Now we are going to see the dynamic characteristics. So these are the properties of the system. Zero order system. The output shows a response to the input signal with no delay. It does not include energy storing elements. For example, potentiometer measure linear and rotary displacements. The next characteristic is first order system, where the output approaches its final value gradually, consisting of an energy storage and dissipation element. Second order system, complex and output response. The output response of the sensor oscillates before steady state. The next part is sensor classification. There are three types of classification: passive and active sensors, analog and digital sensor, scalar and vector sensors. So the first one is passive sensor cannot independently sense the input. For example, accelerometer, soil moisture, water level and temperature sensor. Next is active sensor, independently sense the input. For example, radar, sound and laser altimeter sensors. Analog sensor, the response or output of the sensor is somewhat continuous function of the input parameter. For example, temperature sensor, LDR analog pressure sensor and analog Hall effect. The next is digital sensor. The response in binary nature, so designed to overcome the disadvantage of analog sensor. Along with the analog sensor, it also comprises extra electronic bit, for bit conversion. For example, passive infrared PIR sensor and digital temperature sensor. Next is scalar sensor, detect the input parameter only based on its magnitude. The answer for the sensor is a function of magnitude of some input parameter, not affected by the direction of input parameter. For example, temperature. The next one is vector sensor. The response of the sensor depends on the magnitude of the direction and orientation of the input parameters. For example, accelerometer, gyroscope, magnetic field and motion detector sensors. Now I am going to ask one question to all students, that dash are used for sensing things and devices. There are four options. You have to choose any one option for giving the correct answer. So first option is sensor, second actuator, third microcontroller, fourth none of these. Pause the video and write the answer. The correct answer is sensors. Sensors are used for sensing things and devices. Now there are so many types of sensors. We are going to see one by one. The first one is electric sensor. Electric proximity sensor may be contact or non-contact. Simple contact sensors operate by making the sensor and the component complete an electrical circuit. Non-contact electrical proximity sensor rely on the electrical principles of either induction for detecting mills or capacitance for detecting non-mills metals as well. The next sensor is light sensor. Light sensor is also known as a photosensors and one of the important sensors. Light independent resistor or LDR is a simple light sensor available today. The property of LDR is that its resistance is inversely proportional to the intensity of the ambient light. That is, when the intensity of light increases, its resistance decreases and vice versa. So here LDR means light dependent resistors. The next sensor is touch sensor. Detection of this something like touch sensor or finger or a stylus is known as touch sensors. Its name suggests the detection of something. They are classified two types of resistive type and capacitive type. Today's most all modern touch sensors are of capacitive types because they are more accurate and have better signal to noise ratio. The next sensor is range sensor. Range sensing concern detecting how near or far a component is from the sensing position, although they can also be used for as proximity sensors. Distance or range sensors use non-contact analog techniques. Short range sensing between a few millimeters and a few hundred millimeters is also carried out using electrical capacitance, inductance and magnetic technique. Longer range sensing is carried out using transmitted energy waves of various types of, like for example, radio waves, sound waves, and lasers. The next sensor is mechanical sensor. Any suitable mechanical or electrical switch may be adopted because a certain amount of force is required to operate mechanical switch. It is common to use micro switches. Pneumatic sensor. These proximity sensor operate by breaking or disturbing an airflow. The pneumatic proximity sensor is example of a contact type sensor. Optical sensor. In their simplest form, optical proximity sensors operate by breaking a light beam which falls onto a light sensitive device such as photocell. These are examples of non-contact sensors. Care must be exercised with the lighting environment of these sensors. For example, optical sensors can be blinded by flashes from our welding process. Airborne dust and smoke cloud may impede light transmission, etc. The next sensor is speed sensor. These sensors used for detecting the speed of any object or vehicle which is in motion is known as speed sensor. For example, wind speed sensor, speedometer, UDAR, ground space speed radars. Next sensor is temperature sensor. Devices which monitor and track the temperature and give temperatures measurement as an electrical signal are termed as a temperature sensor. This electrical signal will be in the form of voltage and is directly proportional to the temperature measurement. So these are the references. Thank you.